oppose those charged particles. It will try to stop them. It's kind of friction to charged particle flow. This property is called resistance, and its unit is ohm. You see this symbol, horseshoe? This is called ohm. O-H-M. O-H-M. Ohm. Okay? So, for example, if when the temperature is 0, the resistance is 2 ohm. And when the temperature is 100, suppose the resistance is let's say 102 ohm. Okay? Okay? That's it, just randomly I'm just taking that. Okay? So his question can be, two kinds of questions can be asked to you. He can ask you, if the temperature is 60 degrees centigrade, what will be the resistance? Okay? The formula for the resistance thermometer is exactly the same. The same formula. It says R theta minus R naught divided by R 100 minus R naught is equal to theta by 100.
Sir, the only difference is that in this question
we have length.
Okay, sir.
Length of the mercury column, and here we have the resistance, the thermometric property only changes. Okay. Otherwise, the formula is exactly same. Okay. So the resistance of the conductor when the temperature will be 60, I don't know that. So R naught to this is 204 and minus 2 is equals to temperature is 60 divided by 100. So it will be x minus 2 divided by, let's say this is 202 is equals to, this is 3 by 5 and cross multiply. Okay, this goes x minus 2 equals to, you have the calculator?
Yes, sir.
Okay, this is going in decimals. Okay, just get me the answer. What do you have? 3 multiplied
121.2. 121.2 minus plus 2. It would be
what will be the answer?
123.2. 123.2.
123.2. That will be the resistance. Understand? It's exactly the same concept. Okay? Okay? आगे चल.
Yes, sir.
ये वाली साइड में
Another thing in that chapter, is thermocouples. And you remember the thermocouple. In the thermocouple, you know, we have two wires, and this is the other wire, and they made of different materials. For example, this outer wire is made of copper, and the inner wire is made of iron, and they have two junctions. This is called the, let's say this is called the cold junction, and one is called the hot junction. Okay. So naturally, what happens when you provide when these two junctions, they are at different temperatures. Naturally, this happens. When these two junctions, they are at different temperatures. When there is a temperature difference. For example, if its temperature is theta 1 and its temperature is theta 2. If theta 1 is not equal to theta 2, there is some temperature difference. Automatically, naturally what happens? Voltage is produced. EMF is produced. And that is shown here on this voltmeter. What does this voltmeter do? If some voltage is produced, the pointer of the voltmeter will deflect. Its deflection, it deflects a smaller angle or a larger angle. The deflection of the voltmeter, the pointer of the voltmeter, that will tell you that the voltage is produced. And when the voltage is produced, when there is a temperature difference between these two. Okay? The voltage is produced, voltage is also given another name. Voltage is also given another name, we call it EMF.
EMF.
In this case, we also call it EMF, electromotive force. So now you see what will happen if there is a temperature difference between the two junctions. EMF will be induced, and the rule is that the EMF induced is directly proportional to the temperature difference. EMF induced is directly proportional to the temperature difference here.
Which means that
The greater the temperature difference, the greater will be the EMF induced. The smaller the temperature difference, the smaller amount of EMF will be produced. For example, in your exam somewhere, we have a numerical. In that numerical, he says when the temperature and the EMF. He says if the temperature is what's near. He is talking about a furnace. He says if in a furnace the temperature is 600 degrees centigrade, the EMF induced is 6 volt. If the temperature is 700 degrees centigrade, the EMF induced is 7 volt. If the temperature is 890 degrees centigrade, what will be the voltage? Okay, what will be the EMF? That is the question which is given in your paper, one of your papers. So, what you will do, you will write, the question is, the boss dekhega, I will write that question, which I use in numericals. The equation is difference of temperatures. I can write it like this. Temperature 2 minus temperature 1 divided by temperature 3 minus temperature 2 equals to EMF 2 minus EMF 1 divided by EMF 3 minus EMF 2. Same number डाल. For example, if I am using here theta 2, the EMF 2. If I am using here theta 1, I can write EMF 1. Okay, अभी देखो समझ आएगा. Theta 1, 6. What is theta 2? 700. अभी देखो मैं वैल्यू डालता हूँ. So it will be 700 minus theta 1 is 600 divided by
800
theta 3 890 minus 700
is equal to
EMF 2, that is the EMF 2, 7 volt minus EMF 1 6 divided by EMF number 3, which is question basically, minus EMF 7. Okay, so it will be 100 divided by,
190.
so it will be
190.
and equals to 1 divided by x minus 7. So it will be something like 10 divided by 19 is equal to 1 by x minus 7.
19
So-
by x minus 7.
So x minus 7 equals to 19 by 10. So x will be equal to, this is 1.9 I think, and plus 7. So what will be the answer? 8.9 volt. So the EMF which will be shown on the voltmeter
Would be
of the thermocouple when the temperature in the furnace is 890, how much voltage will be shown on the voltmeter? 8.9 volt. Do you understand?
yes.
So these are the basic three kinds of numericals which come in the thermometer. And one last thing that is not a numerical, it's a theoretical thing which I would like to share with you about thermometers. Is down? I can run it.
Yes, sir.
Okay. So you see, in the thermometers, you see there are two properties about thermometers. One is called range, and the other one is called sensitivity. One is called range, and the other one is called sensitivity. Okay? Yeah, sensitivity. What is the meaning of range of a thermometer? For example, if I have a thermometer, for example, suppose I have a thermometer here, and this thermometer, the smallest temperature, the lowest temperature it can read is 0, and the highest, suppose, is 40 degrees centigrade. Suppose this is A. Suppose I have, in the same length, I have another thermometer, and the smallest temperature it can read is minus 10 degree, and the highest temperature it can read is, let's say, 120 degrees centigrade. You see, range means the lowest temperature a thermometer can read, can measure, and the highest temperature that it can measure. So from the highest temperature, just subtract the lowest temperature. So range for the thermometer A will be 40 minus 0, and it will be 40. Range for the B will be 120 minus 10,
130.
and it will be 120 plus 10, and it will be 130. So range of a thermometer means that the lowest temperature and the highest temperature the thermometer can measure, the difference between them. That is called the range of the thermometer. Sensitivity, on the other hand, means, I can explain you with an example. For example, let's say if I am showing you a bulb, and this is another bulb. I am showing you two thermometers, and I am showing you the capillary and the bulb. This is A, this is B, and both of them are subject to, let's say, the mercury level is here, and the mercury level is here. So the level of the mercury is same in both of them. Suppose I subject them, both of them, to a change of 10 degrees centigrade. Both the thermometers are subject to a change of 10 degrees centigrade temperature. Both of them undergoing, we put them in some environment where we will provide them a 10 degrees centigrade change in the temperature. And I observe that this is the initial length of the mercury. And I observe that there is a change, this much is the change for 10 degrees centigrade in A. But in B, for the 10 degrees centigrade, this much is the change. You see that temperature change in both the thermometers is same. But the length of the mercury, the change in the length of the mercury for the same change in temperature in both the thermometers is different from each other. Here, for the 10 degree change, the change in the length of the mercury is just this. But here, for the same change in temperature, the change in the mercury, the length of the mercury column is this much. The larger the change in the length of the mercury column, the larger the change in the length of the mercury column, the more sensitive that thermometer is. They have the same length of the thermometer, but the one which shows a larger change in the length, that is more sensitive. You see, if you go in the proper definition, the change in the length of the mercury column for every degree rise or fall. The one which will show larger change in the length, that will be more sensitive. There are some methods, and these are frequently asked questions. How you can make a thermometer more sensitive? This is a very, very famous question. How you can make a thermometer more sensitive? You see, this capillary, the one method is the bore of the capillary.
It is both.
Spelling might be wrong. The bore of the capillary. That bore should be narrow. The diameter of that bore, this capillary in which that mercury column travels, that capillary should have very small diameter. The thermometers which have the bore of that capillary is smaller, that will be more sensitive, because in them the mercury will travel a longer length. Okay? The second thing can be the bulb should be larger. This is the bulb. That bulb should be larger, but only the bulb being larger does not mean anything. The bulb larger means that the volume
Of the mercury.
of mercury should be larger. There should be more amount of mercury in that bulb, because you know the mercury is a liquid, and the larger the volume, the larger will be the expansion. If the amount of mercury is smaller, there will be a smaller expansion. But if there is larger amount of mercury, there will be a larger expansion. So this sentence it's not enough if you say the bulb of the thermometer should be larger. No. There should be larger bulb with more amount of mercury in it.
Okay, sir.
Another thing is, the last thing is that you should use a liquid
Which is more sensitive.
which
It will travel more.
expands
The most.
more. For example, if you have water in one thermometer and mercury in another thermometer, the water expands more. Naturally, it expands more than mercury. So, the thermometers which have that liquid, because it's a comparative term, it's relative to, you compare it with something. No? So, if in one thermometer you have mercury and in one thermometer you have water, the one which have water, because water expands more than mercury. So the sensitivity also depends upon the liquid which you are using.
Yes.
Because if the liquid expands more, the thermometer form will be more sensitive. The last thing is that the range and sensitivity, they are opposite to each other. The thermometer which will have larger range will have less sensitivity, or the thermometer which have lower range will have more.
So they are indirectly proportional.
Kind of, they are opposite to each other. So somebody asks you which one has the greatest range and which one has the greatest, for example, they give you 4 thermometers and they ask you which one has the greatest range and which one has the greatest sensitivity. The one who has the greatest range will have the least sensitivity, and the one with the least range will have the greatest sensitivity. And another very important sentence just came in my mind. When sometimes they ask you why a thermocouple is a better thermometer,
What is
and sometimes people, students write that it is more sensitive. And I have read in the exam reports that he says it is not more sensitive. We do not know, we are not sure whether a thermocouple is a more sensitive thing or not. So when you write the benefits of using a thermocouple, don't write it is more sensitive. It is not.
Wider range.
It has wider range, yes. It can measure varying temperatures very fastly. It is portable. With the help of the thermocouple, by using a probe, if you have studied its theory, you can take the temperature at a distance of a hot body. But do not write in benefits that it is more sensitive. Okay? For example, if this thing came 3 times in the paper and we check the marking scheme, he properly write there that if somebody says it's more sensitive, cut marks. Cut marks. Okay? Sorry, thank you very much everybody. Today is 22nd of September 2020. My name is Ferhan Mazher. Right now we were with 10 Cambridge class and we were discussing numericals and sensitivity and range of your thermometers. So thank you very much. Have a good day. God bless you all. Bye bye.